Hi, my name is Monica Bernabe, and this is my final project for our introductory statistics course. So, for this project, I analyzed the survey data that was collected at the beginning of the semester. Um, all of the analysis and visuals that we made with the data was created using StatCrunch, which allowed me to see the data, clean the data. I was able to run summary statistics, create graphs, and perform different statistical tests. So, throughout the presentation, I'm going to be talking about um, different statistical processes like um, organizing the data, confidence intervals, hypothesis tests, regression analysis, among other things. So, my goal is to demonstrate not only what the data is telling us, but also how statistical methods that we learned in this class can be applied to real life scenarios. So for our survey data, um, the data that we used throughout the semester was from a short survey that we completed as a class assignment. So all of the students were able to take the survey, and then we were able to take all of those answers and convert them into data. So overall, this is considered convenience sampling because we were surveying our specific class rather than being selected randomly. So because of this, it's kind of hard to generalize the results um, if we were, for example, applying it to the whole population. But even then, it's still useful for learning and for practicing the different skills that we learned. Um, if we had done more random sampling, then this is where would be more inclined to do generalized results, which is what you want when you're surveying and when you're analyzing new data. So, our data had both categorical variables and quantitative variables. So, depending on what kind of variable we had, this was this was a determining factor in what kind of analysis I was able to do. Um, so, categorical data is basically like different categories or groups or like more like descriptive things. Kind of we it doesn't have any real value in terms of like numbers, and which leads me to the other definition of quantitative data. And then this is where it has numerical values that represent actual amounts or measurements. So for our survey questions, we were asked to pick 5 different questions. So the ones that I chose specifically was to pick a number between 1 through 4, age, burritos or tacos, what city do you live in, and should college be free? So after everyone answered their own different questions, when we were looking at it on StatCrunch, this is where we got to see all of the data, all of the messiness that we also cleaned up that I will be talking more about in my next slide. Um, but we were also able to look at other definitions, like let's say um, discrete versus continuous um, numbers, like discrete being countable values and continuous being numerical values like age. Um, but we also had binary variables, which would be categorical but with 2 possible responses. So this would be your yes and no answers, like should college be free, yes or no, that would be the binary variable. And we also had nominal variables, like and then this is where it was categories with no natural order, like cities or what kind of food you like for the burritos and tacos. um and yeah, so here we have the 5 different questions that I chose. um And I just wanted to go a little bit more into what each of the questions, what type of data it was. So, picking a number 1 through 4, this was discrete quantitative data. Age was continuous quantitative. Um, Burritos versus tacos, this was categorical data. City of residence, also categorical. And should college be free? This is where it's binary categorical. Um, So, understanding which type of variable is really important when you're determining what kind of statistical tools you're going to be using. And so, when we were practicing in StatCrunch, it was necessary to know what kind of data you were dealing with, because that depended what kind of analysis you were able to run with what question and what data. Um, so, in cleaning the data, when we first opened up all of it, um, this is where we had to go through the data, make sure that everything was, for one, spelled correctly, because if it wasn't spelled correctly, then it was counted as 2 different things. Or in the written in responses, like yes, should college be free, or yes or no. Sometimes different students would say yes, or yeah, or yup, and then that would change the consistency of the categories. And so that's where it was my responsibility to go back and clean it up a little bit, so that when we are running analysis, it would be consistent. Um, so I also had to take out, like, let's say, like, what city do you live in? If it was a random, like, made up city, I would have to take it off. Or like pick a number 1 through 4. If they put 5, this would also be something that I would not be able to use, and then it would just be missing data. Um, so I made sure that all of the entries were proper and that they were in accurate, because at the end of the day, you have to have accurate data for accurate analysis. So after we had cleaned up all of the data, this is where we were able to start playing with more interesting features of StatCrunch. So, for example, we did visuals. Um, Once the data set was clean, this is one of the first things that we did was create different types of graphs, like bar charts or scatter plots, like what you see there. So this scatter plot that I did was for age and picking a number 1 through 4. So this was comparing 2 different variables at the same time. So right away, we're able to see that for the most part, majority of students answered number 3, because that just has more dots in the line. And just quickly looking at it, it looks like the majority of answers were kind of grouped more towards under 30. And that also might have just been the type of population that we had. Again, it's not very random sampling. So um, it's a college course. Sometimes they're going to be on the younger side. Um, and those that are completely out of the range, those are our outliers, which I will go over a little bit more later on. Um, so yeah, so we were able to do different types of graphs. Like, let's see. So this one is obviously a pie chart. I feel like this is one that we are very used to seeing. So a pie chart was I made this pie chart for people that chose either burritos or tacos. So right away we can see that there's more red, which means that people chose tacos over burritos, and that because it has more area, this is where um, we can easily see that that's where the majority was. And so visuals are really important for you to be able to analyze data quickly without, you know, actually doing any formal analysis. Um, so this one is a histogram. So this one can this one was done with the age groups of the people that had answered the survey, and it was also with um, well this was analyzing how old are you. So um, when we're looking at the histogram, we can see that the majority of data, those really tall graphs, are more towards the right. So that is when we can see that the majority of students are around under 25, with the most amount of students being 18 to 20 years old. Um, and so a histogram is also a really great way to see the quantities of the different variables that we have. Um, and yeah. Another thing that I also do want to go over is that sometimes graphs can be misleading. So we have to be careful about what we see in advertising and the news or in marketing because when type of data is presented in a different way, it can visually change the truth that they're trying to show. So, like for example, the y axis might not start at 0, or the x axis has different spacing, or the scales are compressed or stretched out, and or like cherry picking categories. All of these different examples are how um, bias can show up in data visualization. And so, for example, in marketing, um, humans are very visual people. And when we look at a graph, we can make up our minds very quickly about what it's trying to say, especially if it's distorted, right? So, this is where knowing the background of it is important so that you know to avoid any bias. You can see, is this accurate data? Is it accurately being presented? And yeah, so it's overall important in your real life day to day too. Um, Another thing that we went over was confidence intervals. So confidence intervals are basically a way to show a range where we think the true value for the population will probably lie based on a sample. So, for example, when we looked at the how old are you from this histogram, um, 95% confidence interval was about 20.95 to 23.78 years. And this was something that we were able to run through StatCrunch. So overall, that means that we're pretty sure that the real average age of everyone in this group is somewhere in that range between the 20.95 to 23.78 years. Um, when we used a 95% confidence level instead, the range got a little bit narrower. So our StatCrunch showed us that um, the ages were now 21.18 to 23.55. So this makes sense because if you want to be more confident, you have to allow for a wider range. And if you're okay with a little less certainty, then this is where the range can be smaller. Um, when I ran the same test with picking a number 1 through 4, um, with that kind of data, with the data from picking a question number 1 or picking a number 1 through 4, um, when we use the 95% confidence interval, um, we were able to see that for the most part, people chose a number between 2.404 to 2.759. So it's likely somewhere within that range. So this one's a little bit tricky to see because for the most part, people were picking whole numbers, and you're not technically it is a number between 1 through 4, but um, statistically speaking, it would be between 2.4 and 2.7, but um, in the data, it looked more like the whole number of 3 was one that was chosen the most. Um, for categorical data, it's a little bit different when you're using confidence intervals because they're estimating more like proportions. So, like when we go back to the burritos versus tacos, 69% of people said that they prefer tacos over burritos. So, that would mean that it would give us a 95% interval of zero point 0.6 to 0.78. So we can say pretty confidently that between 60% and 78% of the population would pick tacos. Um, for another one, like the picking or telling us what city that you live in, um, about 39% live in Oxnard with a confidence interval of 0.294 to 0.486, and 35% live in Ventura with a confidence interval of 0.257 to 0.443. So Oxnard had a slight lead, but the ranges overlapped, so it's not a huge advantage. Um, when I discussed or when I analyzed the should college be free question, 70% said yes, and the 95% interval was 0.61 to 0.79. That tells us that there was a strong support for free college, but the exact percentage could be anywhere within that range. Um, Overall, confidence intervals give us a sense of the uncertainty of our data. So the 95% intervals are wider than 90% intervals because they're more certain, and for both numbers and categories, they'll show the range with the true population values probably fall. So here I have a confidence interval, I have the bell curve, and so the significance levels are at each tail end. And for the majority of data, which is what we're saying, the confidence, like the 95% confidence, means that the majority of data is between the blue part. So for hypothesis testing, um, this was for the how old are you? The results showed that about 20.8% of participants were 19 years old, which is much lower than the expected 50%. The p-value was less than 0.001, so we reject the null hypothesis that half of the participants are 19. So this means that the proportion of 19-year-olds is significantly lower than 0.5, suggesting that most participants in the sample were not 19. Um, so the null, basically like the h of 0, this is when the proportions are equal and um, like let's say for burritos versus tacos, proportions are equal. That's what the 50% is saying. Or the alternative, that's where the proportions are different. So there would be um, a change between the two, like there would be a majority, the proportions would be different. So some real life examples would be like medicine. So this would be like if we're testing a new drug, and if it works better than standard treatment. We could also apply this to education, like testing if a new teaching method is actually improving scores. And so we are seeing, um, if we can reject the null hypothesis or fail to reject the null hypothesis, which would mean we accept the alternative, but we're not supposed to say that because it, that's just the likelihood, but we can't say it with 100% certainty. Um, but overall, hypothesis tests help us make informed decisions about whether observed differences are either due to chance or if they might actually have some significance. This is another one. So this was for, like I was saying, burritos or tacos. So the results show that about 33.7% of participants showed burritos, which is lower than the expected 50% because it should be 50-50. The p-value was 0.0012, so we reject the null hypothesis, that half of the participants prefer burritos. So that means that we are rejecting the idea that it is perfectly split half and half. So this means that the proportion of people who prefer burritos is significantly less than 0.5, suggesting that tacos were the more popular choice. So this is this goes along too with our um, pie chart. And after we did this, um, we can have formal statistical understanding of the background before it, instead of just having a visual um, representation of the data. And so these test results are for the Should College Be Free? So the results showed about 74.5% of participants said that yes, college should be free, which is much higher than the expected 50%. The p value was less than 0.001, so we reject the null hypothesis that only half the participants support free college. This means that there's a significantly greater proportion of people that believe college should be free, showing strong support for the idea of this group. So that's completely accurate. It might also be because, again, we did convenient sampling and students taking the class generally do not make a lot of money because they're full time students. And so this kind of goes along with the idea that a lot of students will probably support free college. Um, but this gives us a chance to statistically analyze that data and say, hey, so after this analysis, there is um, significance with that idea, and it can help prove that instead of just saying like, oh yeah, college students think that college should be free. Well, that sounds more of like an opinion. But when you support it with data and you support it with significance testing and hypothesis testing, then you kind of have like a little bit more of backing up what you're trying to say. And that can change a lot, especially with tuition or financial aid or, real life examples. So, really quickly, the chi-square test is also something that we learned alongside the hypothesis testing, and regressions and correlations. So overall, chi-square tests are usually used to examine independence between categorical variables. So, for example, with the questions that I had chosen, this would be like food preference, in relation to support for free college. So I have the formula there, and then it would ultimately determine if the variables are related or if they're independent. And again, here we have the percentage points of chi-squared distribution and the different degrees of freedom, and we have the chi-square statistic equation here, and yeah. So going along with regression and correlation, um, one thing that I analyzed was age versus picking a number 1 through 4. So the correlation coefficient, before anything, that is something that is measuring the strength and the direction. So this is measured with or defined with the letter R. So the correlation coefficient, or R, um, if you have a positive correlation coefficient, this is a positive correlation. So that means that the slope is pointing upward, kind of like how it is here in this line. It can also have a negative correlation, which means that the point is sloped downward. But if the slope is equal to 0, then that means that there's no relationship between the different variables. So here I have the equation for a regression line, which is used. So if you have different data points, like on a scatter plot, then that's when you figure out the best fit line, and then that regression line is used with this equation. Um, so yeah, so at the end, the b variable would stand for slope, a would be the intercept, and the r squared would be the proportion of variation explained. And so then the regression line would be y equals a plus bxy, um, and then that would be our line. So in this image, I really like this picture because I think it better explains the correlations and the regression lines, or the lines of best fit. So in this first image that we have on the left, um, well, let me backtrack. So the strength of the correlation, or the correlation coefficient, will always be between -1 and 1. So the closer it is to either side determines the strength of relationship. So the closer it is to -1, the more strength it has, or the closest it is to 1 positively is a strong relationship as well. The closer it is to 0 means that there's virtually no relationship between the variables. So the correlation coefficient really is -1 to 1. And so on the left side, it shows a negative perfect, meaning 1, -1 correlation coefficient. And from here on out, we see where the scatter plot dots kind of start to have a moderate negative relationship. In the middle, there's no relationship, meaning that everything is everywhere. There's no relationship between the variables. Um, and indeed, this means that we have a moderate positive relationship where the regression line is starting to be upward, and then at perfect +1, this is also a very strong relationship between the variables, and it's going positive, growing positively, meaning like as one increases, the other one will also increase. But yeah. So this is where I analyze um, the age of students and picking a number 1 through 4. So I use StatCrunch to find the line of best fit. And then that would be the red line right there. And so in this case, it the scatter plot is pretty scattered. So the line is not very I mean, it's slightly positive, meaning that there's a slight correlation, but it's almost horizontal, which means that at that point, the correlation coefficient would be closer to zero. And so it would have a small number or a small strength of correlation. So some real life examples of this could be used for business, like in predicting sales, for advertising budgets, or in healthcare, like predicting blood pressure from exercise hours. That would probably be a negative correlation because blood pressure would decrease as exercise hours increase, and kind of like that. Or like in education, a positive correlation would be predicting test scores to the number of hours studied. So as one increases, the other one would also increase. So regressions also allow us to make predictions based on patterns in data, while correlation quantifies the strength and the direction of the linear relationship. So again, that would also be probably really important in business and predicting sales in from advertising budgets and things like that. Um, but yeah, so some concluding thoughts. Um, this project allowed me to apply the statistical concepts that I learned throughout the semester. Um, some of the things that I learned were data cleaning and preparation, different variable types and visualizations, descriptive stats, confidence intervals, hypothesis testing, chi-square analysis, and correlation and regression tools. So using StatCrunch made it possible to quickly analyze, visualize, and interpret the data while still understanding the theory. This project reinforced how statistical methods can be applied to real world data sets and highlighted the importance of accurate, honest representation of data. But that is everything. So thank you so much, and thank you for watching my presentation.